We can put all those together, much like we did before. Here's an example C program, arith, which takes 3 long arguments and then adds them and multiplies them in various ways. So if we look at this, one thing you see at the beginning is load effective address RDI plus RSI, move it into RAX. In the C code, we have x plus y. So what that means is RDI and RSI must correspond to x and y. Right? And so RAX now is equal to T1, the sum of those things. Now we're adding RDX to RAX and putting the result in RAX. Right? So that's like taking T1, which used to be in RAX, adding RDX, which we can infer must be Z, putting that in T2. So now RAX stands for T2. T1 is gone. Right? If you look at this program, T1 is used and then it's not used later, so we don't need it anymore. So the register RAX can be moved over to T2 instead of T1. Now we have a load effective address, which means we are multiplying RSI times 2 and adding it to RSI and putting that in RDX. So that's the same as doing a multiplication of 3 times whatever's in RSI. And we figured out that RSI was either x or y. Turns out it's y. So RDX is now equal to y times 3, which you don't see a y times 3 anywhere here. You see a y times 48. But 48 is the same as 3 times 16. So what this code is doing is first multiplying by 3 and then multiplying by 16. It's multiplying 16 by doing a shift. And so that's how RDX ends up with y times 48. Again, this was y times 3. Then shifting left by 4 is the same as multiplying by 16. So we multiplied by 3 times 16 to get times 48. Here we have RDI plus RDX. We figured out that RDI is x. RDX is y plus 48. So, and then we're adding 4 more to that. So that is taking x plus 4 plus y times 48. Right? That is exactly what T5 was doing. So we never actually put T3 in a register, or the machine code here, the assembly code, to represent the C code never actually reified T3. It didn't need to because T3 is only used to compute T5. And this illustrates how the compiler rearranges things to get to the assembly code from what you saw in the original C code. So RCX at this point is T5. Then the next thing that happens in the C code is T2 times T5. So relatively straightforwardly, that's what happens here. We multiply RAX times RCX and put the result in RAX. So RAX is the return value here, T2 times T5. And that result is in RAX. Recall that we put results in RAX typically. And so that's why the function here is done, and it executes finally a return. That means return from the function.